In this exercise, we will use network analysis to uncover hidden patterns in a dataset about book purchasing prior to the 2004 US election. Now, this dataset comes from Amazon.com and contains co-purchasing information about books in politics. These co-purchasing data is very important for building recommender systems. You've probably seen the use of this dataset when you go to Amazon.com. If you're looking at a certain product, a book for example, Amazon will recommend other books that other people purchased with this book to you. This co-purchasing data is important to uncover important patterns as well as trends, and it's used widely in marketing. The dataset we have contains co-purchasing data about books, and it's conveniently represented as a network. First, we're going to load Network X and load the data itself. The data is in a data file that has the GML file format, which is another format for storing network data. The nodes in the network represent books. The edges in this dataset represent co-purchasing of these books. So for example, this edge means that there are some customers who purchase these two books together. Let's answer some questions about this dataset. Well, first, there are some straightforward questions about patterns related to specific books. For instance, what books are purchased with worse than Watergate? Now, this is a node in the network itself, and in order to uncover the neighbors of this node, we can actually use the network itself, kind of like a dictionary. If I index the node, it's going to give me a view of the neighbors of this particular node. So I know, for instance, that these are the books that were purchased with this book. There's the neighboring nodes of this node in the network. Another way to get to the same result is to call a function called neighbors. And this function will take a node as a parameter, and it will give us the neighbors of this node. Now, this particular function gave us an iterator, so we need to convert it to a list to see all of the nodes at once. Those are the books that were purchased with worse than Watergate, because they are the neighbors of worse than Watergate as a node in the network. Next, it's asking us to report the shortest path between two books, Move On's 50 Ways to Love Your Country, and Empire. We've probably seen this before. We can call the function shortest path and pass in the network as a parameter, and then the two nodes, node 1 and node 2. So I'm going to copy the name of the book, and that's node 1, and the second book, which is node 2. Now notice that because this book contains apostrophe, I can no longer use this single quote to indicate the string. I'm going to use two quotes here. So that's the shortest path. This basically means that people who bought this book, they also bought the book American Dynasty, and people who bought American Dynasty also bought The Great Unraveling, and people who bought The Great Unraveling bought Rogue Nation, and people who bought Rogue Nation bought Empire. This is a long path in between these two books. Indeed, I picked these two books specifically because the titles are completely opposing, right? From a very patriotic kind of title to a very nationalistic title, for instance, so to speak. So you can see that there are a couple of hops needed here to get from this book to this book. Now let's try to understand what's going on in general. This book was about the 2004, before purchasing data prior to the 2004 US election. So looking at this data can give us some understanding of the mindset of purchasers at that time. One way to take a look at it is to look at the most central books in the network. We can use different centrality measurement to take a look at kind of this information. Let's, for example, take a look at two measurements, degree and betweenness. Now, degree doesn't take into account the whole network structure. It only examines how many neighbors does each node have? So it basically will give us an idea about the books who are co-purchased with so many other books. We can also take a look at betweenness or closeness, because betweenness and closeness examine the whole network structure. So it will give us an idea about the books that were influential overall in the network, not only because they were co-purchased with other books, but because the books that they were co-purchased with were also influential, so to speak. So let's take a look at degree and then betweenness. To calculate the degree, I can use the function degree, and I can pass the network to the function itself, and this will give me a degree view on the nodes. Another way to calculate degree is by calling a function degree centrality. This will normalize degree and it will give me a number between 0 and 1. At the end of the day, I'm going to sort and pick the 5 top ones, so it doesn't really matter if I use degree centrality or degree. But to keep it consistent with betweenness centrality, I'm going to use degree centrality to get a number which ranges from 0 to 1. Now I've got a dictionary, so I want to look at the top 5 ones, and I'm going to simplify my life to convert it to a pandas series, and I'm going to sort values, and sort values ascending will be false because I want to have high degree, and I'm going to take a look at head. Those are the books that were co-purchased with many other books in the data itself. Now I'm going to do the same, but I'm going to look at betweenness centrality instead of degree centrality. And this will give me a different list of books. Now there are some commonalities here, for instance, in between the two lists, but it's not exactly the same. They basically tell us, although a national party no more was purchased with many other books, it's not a very important book, when it comes to the whole data set itself. It's probably, maybe, and that's a hypothesis, maybe it was cheaper, for instance, that's what was more purchased with many other books. But when it comes to betweenness in the network itself, those books were more important. So we would like to understand what's going on. We can take a look at the list, the titles of the book, and try to figure out, the mindset of people who are purchasing this book. On the other hand, this is just the top 5 books. We need to look at everything. One way to look at everything is to break the network into parts that are connected together. This clustering can give us an idea about the mindset of people who are purchasing these books, because people who are purchasing these, books that come together, they're probably kind of belong to some kind of, similar mindset, ideological kind of standpoints. This is something we can examine by looking at the structure of the network. Before doing the community detection, I'm just going to draw the network. And I'm going to draw it without labels because otherwise it will not show up because there are so many titles here. If you take a look at this network, intuitively you will say, okay, probably there are 2 or 3 clusters in this network. There's this cluster of books, and there's this cluster of books, and there's this cluster in the middle, which is connecting them. Already we are seeing something interesting here. What are these books? And what are these books? And what are the books that are in the middle? One way to look at what they mean is to actually probe the identity of these nodes, either by plotting labels or by kind of plotting some IDs and checking against the data. To systematize this process, we're going to use community detection. We're going to use the greedy community modularity detection algorithm. We've already imported the module community from network X. So what we need to do, we need to call the function greedy modularity communities and pass in the network net to it. Next, let's take a look at our communities here. You can see here that, well, let's take a look at the length of this communities first. We've got 4 communities actually in our data, right? So our kind of visual examination of the network resulted in maybe 3 communities, but we already have 4. Let's take a look at these 4 here. This is the first one, and we can scroll through it. We can take a look at the titles of these books. And again, we need to have some background understanding of what's going on in order to try to label these, clusters meaningfully. Let's take a look at this one. Communities 1. Communities 2. And finally, Communities 3. Alright, so what are these books? Community 3 and 4 are the easiest. Community 3 is basically biographies about George Bush and his family. Indeed, I checked The Perfect Wife, and it's a biography of George Bush's wife. Communities 2 is also easy to kind of uncover. Those are books about the Iraq War. Communities 1 and 2 are more interesting. And I am by no means an expert in this domain, and I don't read political books, and I'm not into kind of political discourse, but seems to me that Communities 1 has a left-wing kind of bend into it. It also has some kind of conspiracy taste, which is interesting because it's now associated with some left-wing. It's definitely anti-war, and you can scroll through it. I mean, obviously the anti-war kind of flavor doesn't come also against just, the Bushes. There is this book, for instance. So that's interesting. Community 0, it has more kind of a right-wing bent to it. And it's definitely pro-war, pro-intervention. I mean, this is interesting because it also reflects kind of a bit on the partisanship that we generally have in this country. And this is represented in the purchasing data about books here. What will be useful now is to reflect the communities that we uncovered on the network plot itself. This is an advanced example, and I'm going to use color to encode the different communities of these nodes. There are a couple of steps involved here. First, I need to map each book to its community. Now, the data structure that we've got when we look at communities, it's a list of sets. It's called a frozen set, meaning the set doesn't change, but you can consider it as a set, a list of sets. And I want to map each book to its set. So I'm going to do the following. I'm going to write a dictionary comprehension that will map each book to a number I. The number I represents the community to which the book belongs. So I is going to go over the range of communities from 0 to 3. So I can do for I in 0, 1, 2, 3, or I can do a range length of communities. So I will go over 0, 1, 2, 3, but how about books? Well, book will go over each members of each community. So for book in communities of I. So what we have now, we have a dictionary mapping each book to its community number. 0, 1, 2, and 3. Let's call this one book community. And we're going to use this dictionary to determine the colors of the nodes in our drawing. Now, when we call the function draw in NX, this function takes the network. It also takes an optional parameter called color, node color. But basically, it's a list that indicates the color of each node in the network. Let's say I want to color them to be red. What I can do here, I can say, okay, I want red and multiply it by the length of the nodes in the network. It basically will make all of the nodes to be red. Now, I don't want each one of them to be red. I want to color them based on the community of each one of these nodes. So what I'm going to do here, I'm going to do another conversion here. I'm going to create a list listing the colors of the book. Now, let's say for the sake of this example, I'm going to use red for the what I determine to be more kind of red-wing conservative books. I'm going to use blue for the more kind of left-wingy with a conspiracy flavor books. And I'm going to use red, well, we use red. Let's use maybe yellow for the kind of warish book. And finally, I'm going to use green for the biography books. So this is a list, and the value eventually will be determined by looking at the index of this color. The index of this color will come from the dictionary. So I'm going to access book community for each book. Okay, so a book community for each book. And the book itself will come from network.nodes. And this way I ensure I have the same ordering of the nodes that map to the ordering of the nodes in the network. For each book in network.nodes. Okay, so basically this is a big list stating the colors of the node. That's it. And those colors of these nodes were constructed by consulting the community of the book in the book community dictionary and mapping it to a color. Next, instead of passing just one color, I'm going to pass the book color as a parameter here. And I've got this network now as color. I'm just going to try it a couple of times to get a clean layout, such as this one. Okay, so again, we get the typical kind of partisanship picture. Big two clusters, red and blue, and two clusters in between. And the two clusters in between seems to be maybe a bit more neutral, just, you know, biographies, history of the war and biographies of the family. And that's what we're having in here. So this dataset, which is purchasing dataset, enabled us by applying network analysis methods to uncover kind of the mindset of readers of these books during that time period.